Welcome to lesson 3.5 on the Pythagorean theorem. So you know it from before. In words, it says if the sum of the squares of the two shorter sides of a triangle is equal to the square of the longest side, then we must be looking at a right angled triangle. So then we could say the triangle is right angled. And right angled means that it is a 90-degree angle in that triangle. So the other thing it says that in a right triangle, the backwards of it, the opposite, the inverse of that, is that in a right triangle, the sum of the squares of the two shorter sides of a triangle is equal to, if we've got this triangle over on the right, it's going to be a squared plus b squared is going to be equal to the sum of, the square of the hypotenuse, which is c squared. So c is your hypotenuse. It's always across from the right angle. So in this space here, we're going to write the sum of the squares is equal to the square of the hypotenuse. And the formula that you've seen before, a squared plus b squared equals c squared, where a and b are the short sides or the legs, and c is the hypotenuse. So a couple things we're going to remember. That for our work, we're going to express all answers as integers or fractions or mixed radicals. This means, right here, this means no decimals. So we're going to leave things as mixed radical means we're going to do a simplified square root. So the first one, we've got a right angle, so across from that is c, and then a and b. So a squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared. 36 plus 64. So 100 equals c squared. Square root both sides. We end up with c equals 10. And in this case, the units are centimeters. So we can't forget units. I'm going to make a little note. Units, because you have to remember the units. Next one. This time, we have c already. So if this is a and b, and it doesn't matter, it could be b or a, we're going to do a variation on the Pythagorean. I'm going to say that a squared is equal to c squared minus b squared. And that means that a squared equals c squared is 13. So 13 squared minus 5 squared. So a squared is 169 minus 25. A squared is 144. I'm going to square root both sides. And we get that a equals 12. So, and units, 12 feet. So a equals 12 feet. Because you got to remember those units. The next one, let's see what we're solving for. That's going to be c, so that's what we're solving for. So we'll use c squared equals a squared plus b squared. That's just a variation on Pythagorean theorem. So a and b. A squared is 2 squared plus b squared is 4 squared. So I get 4 plus 16. So I get c squared equals 20. If I want c by itself, I'm going to have to square root both sides. This is the first time where we haven't had a, quote, nice number that we're taking the square root. It's not a perfect square. So I get c equals root 20, but I can simplify it because 20 could be root 4 times root 5. So I get c equals 2 root 5, and then my units are inches. So that's how it ties in with the rest of this whole unit 3 on radicals. Okay, our unknown side here is c, a, and b. So c squared equals a squared plus b squared. Oh, tip. If your b's look like 6's, because sometimes b and 6 might look the same, change your b to a capital B. It works just fine. I'll try to remember to do that for the rest of the examples I do. So a squared is root 14 squared plus b squared is 6 squared. Well, root 14 squared, the square and the square root cancel each other out. So that's 14 plus 36. So c squared equals 50. I'm going to square root both sides and only take the positive because it's an actual distance. So c equals root 50. 50 has a 25 as one of its factors, which is a lovely perfect square. So I get c equals 5 root 2, and this one is also with a unit of inches. E. I'm solving for this. C is across from it, so a and b. So a squared equals c squared minus b squared. So 6 squared minus, inside brackets, 2 root 3 squared. So that's 36 minus, I'm going to distribute the exponent of 2 onto both parts. So that's going to be 2 squared times root 3 squared. So that's 36 minus 4 times the square of a square root. They cancel each other out, so 4 times 3. So I get a squared equals 36 minus 12. So a squared equals 24. There's a perfect square hiding inside there. It is a 4. So I can write it as, I jumped a step. I'm going to square root both sides. So that leaves that a equals, I'm going to go directly to root 4 root 6 here. So a equals 2 root 6 centimeters. Okay, question 2. A rectangle ABCD has sides AB. So AB is the shorter one and BC is the longer one. So I'm just going to call that AB, make that 8, and then BC would be 15, and then D. It wants us to find the length of this. So I'm going to use this triangle inside the rectangle. I'm going to use ABC. So BAC. It wants us to find the diagonal. So we don't know what that one is, but we know that that is 8 and that is 15. So I'm going to call this one X. Normally we call it C, but because we already have a C, that might get complicated, but it's the hypotenuse. So in this one, we'd have x squared equals the two other sides squared. So 8 squared plus 15 squared. So 64 plus 225. And that gives me 289. So x squared equals 289. Square root both sides. And I think that's this. I think the square root of 289, I think it's like a good one. I think it's 17. Hey, I was right. So that gives us that x equals 17. They didn't say any units here, so I'm just going to write the word units to show that I remembered that there were supposed to be units, but that the question didn't tell me any of the units. It was asked in words. It asked us to find the length of the diagonal. So because it was asked in words, we're going to answer in words. We're going to say, therefore, the diagonal is 17 units. Question 3. This one looks like a great one for classwork. And then question 4 is also like really similar stuff with diagonals. And then question 5 is the same thing all over yet again. So I don't even know. We're not going to bother right now. Question 6, an equilateral triangle. So an equilateral triangle has a side length A, B, I'm going to call that C. Side length of 6. That means all of them are 6. It wants us to find the height. So to find the height of this one and the area of the triangle, because if we can get the height, then we could find the area. So if I look at the triangle that I just made yellow, it's going to be 3 on the bottom, H for the height, and 6 is going to be the hypotenuse. So A, we'll call it H anyway. H squared is going to equal C squared minus A squared. So that's 36 squared minus 3, oh, sorry, not 36 squared. It's just 6 squared, which is 36. So 36 minus 9, which is 27. And then we're going to have to simplify it. So if I get H squared equals 27, take the square root of both sides. So H equals root 27. But I know that 27 has a perfect square as a factor, so root 9 times root 3. So H equals 3 root 3 units. So that was the first thing they wanted us to find. So found the height. And then they also asked us to find the area. So for a triangle, area equals base times height divided by 2. So the base is 6 units. The height is 3 root 3 units divided by 2. I'm going to multiply the whole top first. So 6 times 3 is 18 root 3 over 2. And now I'm going to simplify. So I have 18 divided by 2. So I deal with a fraction. So it's going to give me that my area is 9 root 3. And area is always in units squared. So the area is in units squared. Because it was asked in words, we'll answer in words. Therefore, the height is 3 root 3 units. The area is 9 root 3 units squared. Okay. Question 7. In the given diagram, we have angles CAB and CBD, and they're both right angles. So CAB is right here, so I'm going to draw it as a right angle. That means we can Pythagorean theorem it. And it said CBD is also a right angle. Tells us a few more things. It says AC is 8 root 3. AB is 6 root 3. Tells us that CD is 20, and it wants us to find the length of BD. So if we look at triangle CBD, we only know one side, the 20. But if we can find out this side, CB, then we can find out the red side, BD. And we can find that green squiggly side because we can look at the triangle I've just colored blue now. And if I call this X, let's call that X. So X squared is going to equal 8 root 3 squared plus 6 root 3 squared. So I'm going to distribute the squares on all of these. So 8 squared times root 3 squared is 64 times 3. And then 6 squared times root 3 squared is 36 times 3. So 64 times 3 is 192. 36 times 3 is 108. So we get x squared equals 300. I'm going to go right here. That means x, because I square root both sides. So x is going to equal to, I'm going to break out the 100 right away. So x is going to equal 10 root 3. So now we have, so that was the first thing we did. Second, now we have this triangle where we know that this is 20, we know that this is 10 root 3, and we're trying to find BD. So BD squared is going to equal the hypotenuse, c squared, minus our other side, minus a squared. So it's going to equal 20 squared minus 10 root 3 squared. So that's going to be 20 squared minus 100 times 3. I've just squared both parts of those things. So that's 400 minus 300. So that equal BD squared equals 100. but we want BD, so we square root both sides, and we get that BD equals 10. Again, no units given, so we can just write units. And asked in words, so we answer in words. Therefore, the length of BD is 10 units. Question 9. Question 9's a little bit trickier. Question 9, if we have a ladder placed against a vertical wall of building. So the first thing I'm going to do is I'm going to draw the ground. So here's the ground. And then I'm going to draw my ladder. So if my ladder is here, it's placed against a building, and this is just going to be the building. The ladder is 6.5 meters long. So the ladder is 6.5 meters long. The foot of the ladder is 3.9 meters from the base of the building. So that means this length here is 3.9 meters. So it tells us it starts like this, and then it says the top of the ladder slips down 2.7 meters. How far will the foot? So they want us to find out how far will the foot of the ladder slide. I thought that was going to go a nice straight line. So they're telling us that in the second picture, we're going to have, oh, that's not straight. We had the ground, we had the wall, and our ladder is now, it's fallen down. So now our ladder is like, it's, how far did it fall down? It told us the top of the ladder slips 2.7 meters down. So if this was X here, and it started off at that height of X, this new, and then it slid down 2.7 meters. So that amount there was 2.7. That means the amount remaining here is going to be X minus 2.7, because the whole thing was X and now it's 2.7. But really they want to know if it was before 3.9. I'm going to use a different color. If it was 3.9, they want to know how much is, I'm going to get green highlighter, how much did the foot slip? Okay, so how far did the foot slide? That's going to be this green amount that we're going to figure out. So, and the ladder is still going to be 6.5 because the ladder doesn't grow or shrink. So if I can figure out what X is, then I would know this amount, and then I could work backwards and figure out this whole big amount, and then I could figure out what that green colored in was. So we're going to do that. First, we're going to find X, and we'll do that over in this triangle on the left. So X squared is going to equal the hypotenuse squared, because that was a right angle. So 6.5 squared minus 3.9 squared. This one, it looks like we can't have decimals. So 6.5 squared is 42.25 minus 3.9 squared, which is 15.21. 42.25 minus 15.21 gives 27.04. Square root both sides, and we get that X equals 5.2. So X equals 5.2 meters. So X equals 5.2. So over here, the whole big thing was 5.2. And 5.2 minus 2.7 means that that red thing isn't, oh, I'm just going to erase until I unsquiggle. So if the whole thing, if X was 5.2, this whole thing, then that red part, 5.2 minus 2.7 is 2.5. Okay, so we want to find how much that highlighted green part was. Let's call it like M, just to give it a letter, because we used X already. So if I now look at, I'm going to highlight in pink. In the pink triangle, the height is 2.5, the hypotenuse is 6.5, and the bottom pink thing is going to be 3.9 plus M. So let's take a look at that. The second thing we'll have is that 2.5 squared. Oh no, let's figure out that whole unknown side. Let's do that. This whole side. Let's figure out what this is. And then when we subtract 3.9 from it, we'll get M. So, I don't know, another letter, K. So, K squared is going to equal, because that's a right angle, the hypotenuse, 6.5 squared, minus 2.5. So, 6.5 squared is 42.25. Oh, right, we did that before. 2.5 squared is 6.25. So, 42.25 minus 6.25 is 36. Another nice number. So that gives us that K equals 6 meters. But now we want to figure out how big is M. And M was in green. So M is going to equal K minus the 39 that already was there. So M equals K minus the 3.9 that it started off with. So that's 6 minus 3.9. So M equals 2.1, and then the units are meters. Poor choice of a letter, because it's not great when the M's match. Okay, that one's kind of tricky, but you are going to have to know how to do it. Question 10, and this is our last one of the unit. A square ABCD, so it's a key fact that it's a square, whose area is 100 centimeters. So right away, I'm thinking if I got a square and its area equals 100 centimeters squared, that tells me that each side length is going to be 10 centimeters. So I already know that from D to C is going to be 10 centimeters. It's inscribed in a semicircular region. A and B are on the semicircle, and C and D are on the diameter. They want us to find the radius of the circle. So they want us to find this. So my eye is drawn to this right triangle, and I'm going to draw it out bigger. So it has, D to C is a whole 10 centimeters, but that's going to be half of it. So from D to O is going to be 5 centimeters. We know that the square, we figured out that every side length of the square is 10. So that's, let's use a different color. So we know that that's 10 centimeters. So that's 10 centimeters. And they want us to find the radius. So the radius squared is going to equal, because that was across from a square root sign. That's my C. So radius squared is going to equal A squared plus B squared. So it's going to be, 5 squared plus 10 squared. So that's 25 plus 100. So R squared equals 125. And if R squared equals 125, I'm going to take the square root of both sides and get that R equals root 125. But we can simplify that. One of its factors is 25, leaving the other factor of 5. And we do that because then I can take out that perfect square, and I'm left with 5 root 5. And this question did have units. So it's 5 root 5 centimeters. And they asked us in words, so we answer in words. Therefore, the radius is 5 root 5 centimeters. And that's it. So thank you for watching Unit 3.